Good day all. We have been talking about theoretical aspects in the past modules. Today we are going practically. We'll be looking at module 9, which is the econometric software and its application. By way of module objectives, we should be looking at explaining why software literacy is essential for credible econometric analysis. We'll be looking at using at least one major econometric platform to import, manage, and transform data sets for econometric application. We'll also be looking at estimate and interpret common econometric models, conduct hypothesis testing, and report results using software output responsibly. We'll be looking at diagnosing model problems. We'll also be looking at applying advanced software features to implement panel data models. By way of introduction, modern econometrics is inseparable from software. While the theoretical foundations of estimations, inference, and identification determine what is valid, econometric software determines what is feasible. How quickly you can clean data, estimate modules, test hypotheses, diagnose with specification, and communicate results. In applied work, whether in policy, evaluation, finance, development, economics, labor econometrics, industrial organization, or market economics, software is a bridge between econometric model and evidence from the data. This module develops practical competence in using econometric software as an integral part of econometric workflow. We begin by clarifying how packages like Stata, Arrow, eView, Regrets, Python, and specialized tools operationalize econometric concepts. Data sets become structured objects, estimators become command functions, standard errors become options, and model diagnostics become post-estimation tools and plots. We then focus on hands-on application, regression analysis, hypothesis testing, model diagnostics, and we look at usable research practices. Finally, we move into advanced features that extend the core linear model toolkit to panel data, time series, and limited dependent variable models. By the end of this module, we should not only be able to run regressions, but also design an alternate pipeline, import data, document and clean it, provide descriptive statistics and visualization, estimate models correctly, validate assumptions, respond to specific evidence, present output in the form of suitable for report writing. This emphasis throughout is on econometric reasoning with software, not software as a replacement for reasoning. Let's look at our first software, Stata. Stata is widely used in applied microeconomics and policy evaluation because it provides a consistent command syntax, integrated data management, and strong support for standard econometric estimator and robot inferences. A Stata workflow typically relies on do files, that is scripts, log files, record of commands, and outputs. Some of the operations that you can carry out here is data import, data management, descriptive statistics, estimation, post-estimation. You can also carry out reports in here, and these are the commands for all of them. Now, how do we set up a project in Stata? First, load data. Use my data dot clear. 2, inspect and clean. These are the words you can use here. Describe, summarize income, detail, and all. These are the key phrases you can use. 3, baseline OLS with robust SE. 4, carry out the diagnostics. 5, export a result table when you are done. Let's look at the next software. We have Arrow. Arrow is another software. It's an open-ended source statistical program with a vast ecosystem. In econometrics, Arrow is valued for flexibility, cutting-edge methods, and strong, reproducible research tools. The cost of flexibility is that you have to manage packages and write code more explicitly than menu-driven tools. It does not have much menu. A practical econometric workflow in Arrow combines 1, data manipulation, 2, estimation, inference, and robust SE. It also combines also reporting. Some of the common tools here that you can carry out with Arrow includes data imports using these codes, data transformation, OLS and GML, GME, can carry out robust SE, panel data, can carry out time series here, can carry out limited dependent variable models. You can also carry out reproductivity. Now, how do you start up a project with Arrow? First, load packages. Second, you import the data. Third, create the variables. Then fourth, you estimate your OLS. Five, you carry out the robust standard errors. Let's look at our next software. This is quite popular, eViews. eViews is a popular econometric package in Econometrics, forecasting and time series analysis. Its interface is designed around time index data structure, that is work files. It provides menu-based tools for estimation and diagnostics with the option of scripting for automation. The strength of eViews include easily handling updated frequencies, frequency conversion, annual, quarterly, or data ranges. It is built in. It has built-in tests for unit truth, for integration, BAR/CM modeling, and forecasting. It is convenient for graphical diagnostics and regression objects. It supports it has strong support for macroeconomic models like ARIMA, GAD, and ACT. Now let's look at how do you set up a new views. You open your file, you open file, go to new, go to work file, choose data frequency there. Then you import your file, your CSV file. You go to open and you import it. They verify your data structure and the series alignment. Let's look at the next one, which is Python. Python has become common in data science and increasingly in econometrics, especially where analysis requires extensive data engineering or integration with machine learning workflows. The stats models library provides classical economic estimators with output similar to traditional packages. Key ideas when you're using Python for econometrics is separate data manipulation from modeling. Be explicit about missing data handling and variable types. Use robust cluster standard errors through the model fit. Reproducibility via notebooks or script via environment plus environment management. These are some of the illustrative codes. Yeah. Import pandas, import stat model. These are some of the codes you use in Python. Now, let's look at how to set up a project in Python. First, you create a visual environment. That is, user use conda or venv. Two, you install packages. That is pipe install pandas. Three, you use Jupyter Notebook or .py script. That is for Python. Let's look at some of the key differences across the softwares. For starters, it is econometrics focused. It has simple syntax. For Arrow, it's flexible. It requires package management. You have to manage it. For eViews, it has strong GUI for time series. It's very good for time series. While Python integrates economics with machine learning. By way of conclusion, econometrics is a practical necessity, but credible econometric analysis depends on how software is used. The same dataset can produce misleading or reliable conclusions depending on the user understanding of model assumptions, inference choices, diagnostics. Throughout this model, we emphasize the discipline workflow. We looked at careful data preparation. We look at correct model specification. We looked at the appropriate standard errors and all. We looked at each softwares. Now, as you continue econometrics, you treat software as an extension of econometric reasoning. Learn the commands and packages, but more importantly, learn why each step is taken and what can go wrong. With these skills, you can approach applied econometric problems with confidence and produce results that are defensible, transparent, and useful for decision making. So in this module, we have practically looked at at the software we have. We have Starter, let's say we have Arrow, then we have eViews, and lastly we have Python. This is very, very trendy, especially Python. And that'll be all for module 9. I'll see you in the last module in this course, module 10.